Hi students, let's talk a little bit about the second derivative test. So what the first derivative gave us as just a quick recap was where on the function's graph the function is increasing and where it's decreasing. Now the second derivative tells us about its shape. So look on our textbook here and you can see that concave up means it's like a cup. So you're facing upward. Your curve is facing upward. Concave down would be the opposite. It's like you're facing downward. Okay? And the second derivative is going to tell us about that. I wanted to also show you something else here. Our rule for what happens with our second derivative. So if our second derivative, second derivative is positive on an interval, meaning greater than 0, then it means that our curve or our graph is concave up. If our second derivative is negative, less than 0, then it means that our curve or our graph is concave down. Okay. Let's go ahead now and work this problem. So we want to find the intervals on which g of x is equal to x plus 1 over x squared, where it's concave up or where it's concave down. So as you probably guess, we need to take some derivatives here. Let's find the first derivative, and let's go ahead and write g of x in a little bit more convenient form. X plus x to the minus 2 power. Same thing as 1 over x squared, using our negative exponent rule for exponents. So our first derivative, g prime of x, is going to be 1 minus 2x to the minus 3, subtracting 1 from that exponent. Minus 2 minus 1 is minus 3. And then the second derivative, g double prime of x, the derivative of a constant is 0. So then we just have to take the derivative of this term. We have this minus, the subtraction also is this minus sign on the term. So it would be like negative 2 times negative 3, which is positive 6, x to the minus 4. And now I'm going to rewrite that as 6 over x to the 4th. It might come in handy when we calculate things. In fact, right away, I hope you can see that we're going to have a problem here if x is equal to 0. That's not going to work too well for us. Let's go ahead and draw our number line right here. And let's mark some values here. So if x is 0, our second derivative, now this is the second derivative, it's undefined. It's not defined because x cannot be 0. We can't divide by 0. So I'll put an ND here. Now what are we looking at? We want to see where on this function, what's the concavity? So we're investigating the second derivative for different values of x. I'm going to put negative 1 over here, positive 1 over here. We would also try to find the critical values, but if I set this equal to 0, I'll just write here critical values question mark. 0 equals 6 over x to the 4th. There are none. There are no critical values. There are no peaks or valleys in this function. Critical values or critical numbers, you can call them either one. Okay. So we need to just find what's the sign from 0 to the left for x, and what is the sign of the second derivative if x is positive. Let's start with negative. So -1 is an easy, good value for me to choose. Let me make a little table of solutions here. So if x is -1, what am I calculating? I want the sign of my second derivative because I want to determine is it concave up or down. So my second derivative is 6 over x to the 4th. And let's call it g of x because that's what our function is called here. So let me erase that. So g double prime of x. And let me just write it here, 6 over x to the 4th, to help me remember what we have to calculate. So if x is -1, we'll have here 6 over -1 to the 4th. When you take +1 or -1 to an even power, it's always going to be positive. So we'll have 6 over 1, or 6, which means that that's a positive number. I can erase here now. Any value of x I choose, -1, -2, -1/2, anything that's smaller than 0, I will get from the second derivative a positive result, meaning what? Concave up over here. Let's try it again for +1 to see what the behavior of the function is for positive values. Well, we're going to have the same thing, 6 divided by 1 to the 4th, which is just 1. So it's positive both on both sides. So bottom line, what does this mean? The function is concave up. Let me spell it right. There we go. -infinity to 0 and 0 to infinity. It's never going to be concave down. I invite you to graph this function. Just put in some values for x here. So probably need about 6, 7, maybe 8 points. Because it's a rational function here, what we're dealing with, it's going to be in 2 parts, and we're going to have asymptotes, vertical and horizontal asymptotes. So you're going to see like part of it in one quadrant and the other part in maybe a diagonal or a quadrant that's next to it. So put in some values for x, positive and negative, and see what happens, what the behavior is, so you can confirm the results that we got. Bye, students.